Conformations. Let us now understand conformations of alkanes. There is a further degree of freedom for each carbon-carbon bond. The torsion angle between the atoms or groups bound to the atoms at each end of the bond. The spatial arrangement described by the torsion angles of the molecule is known as its conformation. In geometry, the angle between two planes is called the dihedral or torsion angle. Conformations of ethane. Ethane molecule, that is C2H6, contains a carbon-carbon single bond with each carbon atom attached to 3 hydrogen atoms. There are infinite number of conformations of ethane. However, there are two extreme cases. One such conformation in which hydrogen atoms attached to two carbons are as close together as possible is called eclipsed conformation. The other, in which hydrogens are as far apart as possible, is known as the staggered conformation. Any other intermediate conformation is called a skew conformation. It may be remembered that in all the conformations, the bond angles and the bond length remains the same. Eclipsed and the staggered conformation can be represented by Sawhorse and Newman projections. The first one is Sawhorse projection. In this projection, the molecule is viewed along the molecular axis. Upper end of the line is slightly tilted towards right or left hand side. The front carbon is shown at the lower end of the line, whereas the rear carbon is shown at the upper end. The lines are inclined at an angle of 120 degrees to each other. Sawhorse projection of eclipsed and staggered conformation of ethane are depicted in given figure. The second type of projection is Newman projections. In this projection, the molecule is viewed at the C single bond C bond head-on. The carbon atom nearer to the I is represented by a point. 3 hydrogen atoms attached to the front carbon are shown by 3 lines drawn at an angle of 120 degrees to each other. The rear carbon atom is represented by a circle and the 3 hydrogen atoms are shown attached to it by the shorter lines drawn at an angle of 120 degrees to each other. The Newman's projection are depicted in the given figure. Relative stability of conformations. Staggered form. In staggered form of ethane, the electron cloud of carbon-hydrogen bond are as far apart as possible. Thus, there are minimum repulsive forces, minimum energy, and maximum stability of the molecule. Eclipsed form. When the staggered form changes into the eclipsed form, the electron clouds of the carbon-hydrogen bond come closer to each other, resulting in increase in electron cloud repulsions. To check the increased repulsive forces, molecule will have to possess more energy and thus has lesser stability. The repulsive interaction between the electron clouds, which affects stability of a conformation, is called torsional strain. Magnitude of torsional strain depends upon the angle of rotation about CC bond. The angle of rotation is also called dihedral angle or torsional angle. Of all the conformations of ethane, the staggered form has the least torsional strain, and the eclipsed form the maximum torsional strain. The energy difference between the two extreme forms is of the order of 12.5 kJ mole inverse, which is very small. It has not been possible to separate and isolate different conformation isomers of ethane.